Okay, so welcome to the session, and I hope all of you are doing good. So let's get started with today's discussion. Today we are going to talk about artificial neural networks, and a lot of things are happening in the field of deep learning and AI. So we thought of starting a series of AI where we will talk about various different types of networks. And the first one which we are going to discuss will be artificial neural network. The idea here is that to give you the understanding about what it is, again, it's not going to be very much in detail because we have only 1 hour, but I'll give you the brief understanding about how it is happening and what it is happening and how this can help you to basically implement things in your day-to-day work as well. So let's get started. So idea here is that data is growing day by day. We are already aware of that. And because of that, many companies are leveraging that data and trying to come up with some of the interesting solutions. Like we have started with Chat GPT. Interestingly, DeepSeek came in the last few weeks back, and because of that, it disrupted the entire AI community. Because earlier people were thinking that we will only have to spend a lot of money for implementing these AI solutions. But as DeepSeek came up with some of the, what do you say, software level changes, and because of that, the entire cost reduced drastically for implementing the entire AI solution. And that is making us motivated that yes, we can very well implement the AI solutions in our companies as well. And soon companies will start implementing the AI solutions in their day-to-day tasks because overall the cost reduced quite drastically. A lot of reduction in the energy and all those things happened. And because of that, companies will soon going to start all these solutions. So now for us to be very much up to date and at the same time to be uh, helping, like to be basically taking help from the AI and going ahead and proceed further is what we should be aiming at. And because of that, we are planning to talk about brief of understanding of all the networks and how it works so that you will also get the idea. And then you can, at least when we are sitting in front of people who are tech savvy and talking about AI and all, so we should be aware as well what's going on. So this session mostly is for all the people who are not aware of the concepts and not aware what it is, what AI is. So that is how this session will be set up so that they will understand. So let's get started. So the idea was, as the data was earlier, the concept of artificial neural network and your concept of AI was since the Second World War, right? This topic is very much people are talking about since the Second World War. But the problem which we were having was data was very less, and at the same time, the processing power was also very less. And because of that, they were not able to implement the proper AI solution. And the Department of Defense in the US, they have spent a lot of money from around 1950s to around 1980s. They have spent a lot of money on AI, but nothing happened because of these two challenges. Right. So after that, they stopped funding this entire AI thing, and people were using the traditional machine learning models, right? And they were very much okay with what's going on in the machine learning models. But there was a guy named as Jeffrey Hinton. So he and his team was working on the AI things, and basically they have come up with a concept of back propagation, right? And that was making things very much powerful. Resource was not getting consumed that much, and that was actually helping us to create the entire AI models quite efficiently. They released the paper in 2006. No one took it seriously. They were like, yeah, that's fine. I think it's not going to help much. But in 2012, when there was a competition happening known as ImageNet, people were using the traditional ML models, and these guys were using the AI model, which they have built using the back propagation. The accuracy which they got was very, very high as compared to the ML models. And then people thought of, okay, something is happening and something happened. And then since 2012, you must have seen a lot of things coming in, self-driving car from Tesla and Waymo, which is the subsidiary of Google. Your Alexa, Siri, all those things came in. At the same time, if I want to predict whether I'm having skin cancer or not, so based on the mobile phone cameras, also I can predict that, right? So those type of technology came in. Since then, it's like going like very powerful. It's growing like very, very, very powerful, right? So that is the brief history, how the things were and how now Google, Meta, and all those companies are having huge amount of data set and they are leveraging that and they are building solutions. And at the same time, they are again automating a lot of things, right? So that is how the things are working. So now let's talk about the first network. Again, inside this, all these concepts, there are various neural networks are available. And after that, a lot of enhancement happened in this entire series, which we will have. We are going to talk about various different networks and various different enhancement which happened, right? So in the today's session, we are going to focus on the ANN, which is artificial neural network. In the next session, which is next week, we are going to talk about the CNN, which is convolutional neural network. And then we are going to talk about RNN, which is recurrent neural network. And after that, we are going to talk about encoder, decoders, and so on. So today's focus is more on the ANN. And in ANN, what happens is that when I have a structured data, right? For example, let's say I'll take two examples. One is of regression and second is of classification. So what is a regression? Regression is nothing but when I have a data set DN. Let's say I'm running my business for last 5 years and I want to go ahead and I want to come up with a solution which can help me to predict something. For example, let's say I'm selling my old cars and I sold almost, let's say 10,000 cars in last 2 years. And I have the data set with me where on what price I sold the car, all those information is there, which type of car it was, and so on and so forth. So I have a dataset DN which consists of all the XIs, where XIs are nothing but the feature of the car. That means whether the car, what is the mileage of the car, right? What is the age of the car, how many kilometers driven, maybe whether the car is automatic or manual, whether the car is accidental or not accidental, right? So these type of information which I have are known as XIs. That is nothing but your independent variable or features of the car. And I have a YI, which is nothing but your price of the car, at which price I sold the car. So this information is with me because I am doing this business for last many years and I have this information with me. So I will take this information and I'll pass it to the machine, right? I'll pass it to the machine. So this information is basically nothing but all your XIs are the real valued number, right? Belongs to the real valued number. And your YI is also belonging to the real valued number, right? Car prices like what? 10,000, 50,000, 60,000, and so on, so forth. So this is my regression equation where I have this information. So basically what happens is that I have the information with me, which consists of all the details about the car and at which price I sold the car. Let's say I have these many records, 10,000 records I have. I will break this data into the training data set, and I will break this data into testing data set. I will train the model on the training data set and I will test the model on the testing data set. And I'll check the accuracy, how the accuracies are. So this model, I can use any different models. I can use linear regression. I can use support vector machine. I can use maybe XGBoost and so on and so forth. But here the model which we are going to build is ANN, artificial neural network. So I can very well use the ANN model as well. I can very well use the power of neural networks as well to do the prediction, right? So that is the idea. That is about the regression point of view. Now, same way, if I come back to the classification point of view, I have a data set DN, which consists of XIs and YI. For example, let's say I am selling a product, right? So which type of people they are, what is the age of the customers, what is the gender of the customers, right? What is the location of the customers, and so on, so forth. These are the information which I have, which is the features, or I can say the independent variables. And yi is basically nothing but my dependent variable, which is nothing but 0 or 1. That means that whether my customer purchased the product or whether my customer did not purchase the product. So I have the xi's and yi such that xi belongs to the real valued number and yi belongs to 0 or 1, where 0 means no and 1 means yes. So this is again one of the data which we are going to use for the model building as well, right? So these are the structured data which I have. For example, if I talk about this was a regression example. For example, let's say I want to talk about the classification. So I have all the information about my customer and whether my customer purchased the product or not, right? 0 means he did not purchase, 1 means he purchased the product. I have this information with me because I am running this business for quite good amount of time and I am collecting that information. So again, I'll do the same thing. I'll split the data into train and test. I will use the training data set for training the model. I'll use the testing data set to test the model. And basically the idea is that this model will predict whether the customer is purchasing the product or not. Let's say prediction is coming out to be this. I can compare with the original. So first one is 0 and 0. That means actual is 0. Prediction is 0 as well. That means it's a correct prediction. Second, 1, 1. Both are 1. That means correct prediction. And third one is 0, 1. It's different. As per the actual data, the customer did not purchase the product. As per the predicted data, customer purchased the product. So this is coming out to be a wrong prediction. And the accuracy is coming out to be 2 by 3. That is 66%. Right? So when we are running the artificial neural networks, then we want this type of structured data, right? Either I have the regression type of data or I have the classification type of data. When we are having images, videos, or any unstructured data, in that case, we have to first clean that and then we can apply the model. But direct data, if I am having, then I can very well go ahead and I can apply the ANN networks, right? For example, let's say I want to predict the salary based on various features. So let me show you how the ANN looks like. So let's say this is my X1, which is nothing but let's say experience of my employee. I have the X2, which is let's say my maybe education of the employee. And X3 is let's say how many years or let's say what is the graduation marks. Okay, so let's say grad marks. So now I have these three inputs which I am going to use for building my model. This is my what? These are my x's. If I go back to this picture, these are the x's which I have, right? So I have this x's with me. In the neural network, what happens is that we are going to pass certain functions, right? So if you see here, let's say these are the functions which I have. So let's say this is my function fn, function fn, function fn, and function fn. Again, let's say I'm passing certain more functions. And let's say this is the outcome fn, fn, and fn. And this is also fn. Before I talk about more in detail in this, the idea is that I am passing my inputs. I am passing my inputs to one of the mathematical functions, right? One of the mathematical functions, and then I am getting the output. This is what a simple network looks like, where I have the multiple x1, x2, and x3. I am passing on the mathematical functions or a mathematical function, and then some output will be coming in, and then that output is the predicted value, right? And once I will get the predicted value, I will compare this predicted value with the actual value. And if difference is more, I will go back and I will change something here. What is that something? We'll discuss that in some time. But that is the overall idea. So when we are having these features, right? And let's say this is my function, mathematical function. This function is connected with the features with certain weights. These are the weights, right? W1, W2, and W3. Let's say I have the X1, which is nothing but your experience of the employee. I have X2, which is, let's say, X2, which is, let's say, education of the employee. And let's say X3, which is the kid's age, right? The employee's kid's age. And I want to predict my salary. So I know that, yes, experience is very important for me to basically go ahead and predict the salary. So the weight which you can see W1, this will have the higher weight, right? The weight of this particular connection will be a higher weight. That means it is going to impact my salary quite heavily, right? So this W1 will be a higher value. Same way, education is also important. May not be that important as your, what do you say, experience, but it is important. So this will have a higher weight as well. May not be as high as what weight I have for the salary, but it will be having higher weight. Kids' age is as such really not important. So in this case, what we will do is we will give the weight as very low weight, or maybe we can make it zero also. That depends what type of algorithm we are using, right? So low weight. So now I want to predict the salary. So I can say that salary is nothing but W1 into X1 plus W2 into X2 plus W3 into X3 plus B into 1. So you'll have one more thing here, which is known as B, and having the coefficient as 1. B is nothing but your bias. This equation is more like what we have studied in our maths also. Y is equal to mx plus c, m1 x1 plus m2 x2 plus m3 x3 plus c, like that. So same equation you can see here as well, where W is nothing but the weight of your X1, which is your experience. W2 is your weight of your education. And W3 is nothing but the weight of your kid's age, right? And B is nothing but your intercept or bias, right? Now here your W3 will be less, as I mentioned earlier. This will be high and this will be high as well. So from this equation, I can get the idea that, okay, if I want to predict the salary, these two features are very important for me. And that is the reason the weightage given to this is quite high. Let's say in the training phase, what happens? What happens is that machine will take this random weight, right? W1 will be a random value. W2 will be a random value. W3 will be a random value. And then what happens? It will do the prediction, right? So let me show you step by step. So this is my first step where I am passing the value in this function. The weight assigned will be some random weight. Let's say W1, 1, W1, sorry. Let's give the name like this. W2, 1. 1 means the first instance, right? W1 is the first weight. This one means first instance. Or I can say first, at the very first, the random weight which was assigned to the machine. And W3, 1. In the very first instance, I will get this and I will predict the salary. Now, once I predict the salary, I will compare the predicted salary with the actual salary. And if the difference is more, that means your actual salary was, let's say, 10,000 and your prediction is coming out to be 2,000. That means the difference is quite high. That means your model is not well trained. Based on the weight which was given to the individual features X1, X2, and X3, I want this weight to be changed because see, I cannot change my X's. X's are nothing but the experiences, the educations, and kids' age, which is a part of the training data. So I cannot change that. I cannot change this actual salary as well because that is coming from my data only, right? The only thing which I can change is this W or these W's. So I will go back and I will fix these W's. right? Machine will fix these W's. There are various concepts like gradient descent and all, which can help me to fix this W's, right? So now in the second instance, what will happen? My W will change. My W will become W12, W12. 2 means the second instance. This will also become a different value. This will also become the different value. So W22, W32, right? During this process, what happens? This weight will change. Maybe this weight will become higher because experience is important for me. This weight will become also higher because education is also important for me. And same way, this weight will become lower because kid's age is not an important feature for me. Again, the prediction will happen. Again, I will get the predicted value and the actual value. Let's say my actual value is 10,000 and the prediction is coming out to be 4,000. So there was certain improvement happened. So again, I want to fine tune this. As of now, still the error is more, right? So again, I will go back and again, I will ask machine to change the weight. So now what will happen? This weight will again further change. This weight will again further change and this weight will again further change. So W1 third instance, W2 third instance and W3 third instance, right? Once I have this, again, it will predict the salary. Again, I will get the predicted salary and the actual salary. Let's say actual salary is 10,000. My prediction is coming out to be 8,000. So now error is becoming less. And this process will go on till the time my reduction is happening between the actuals and predicted, right? And I'm not looking for exact correct prediction, right? I'm not looking for that my prediction is coming out to be 10,000 as well. No, because it will overfit my model. So I want a decent value which is giving me a lesser error. Now, how will I check the error? And I gave the example of one of the records here, right? So you are training actually on the multiple records. You are training on the multiple records. You have the multiple X's, Y. So I have a lot many records here. So this training will happen on all the training data, right? So I just gave you the idea with the one record, how things are happening. And it will happen on multiple records as well. It will happen, right? So it will happen. So now what will happen is that I will calculate for every record how much error I am getting, right? My interest is what? My interest is this error should reduce. What is the error? Error is nothing but the predicted value minus the actual value. If this difference is less, we are good. So there is a concept called MSE, RMSE, all those measures are there, which is known as mean squared error, mean squared error. So the idea is that I want to reduce this. That means MSE can be written as summation of I is equal to 1 to n, yi predicted minus yi actual whole square upon n. What I'm doing here is that I am taking the actual salary, subtracting with the predicted salary which I am getting, right? And then or I can say predicted minus actual, whatever it is. You can write vice versa. It's like square. So that does not matter. So predicted minus actual by square by upon n, right? So predicted value minus the actual value whole square upon n, right? So this should be as low as possible, right? That is the idea. So this includes for all the rows, not only for one row. This includes for all the row. So this should be less. Again, there is one more measure called RMSE, root mean square error, which can be written as square root of MSE, right? If I do the square root of this guy, it is nothing but RMSE. So my RMSE is becoming less. My interest is that to reduce this RMSEs, right? So this is the entire process which we have, which again, I have shown you in this picture as well. Here you can see that we have 4 inputs. This is my first layer where I have 3 functions. I have second layer and then I have the final layer, or I can say the output layer. These layers which are in between are known as hidden layers, and this layer is known as output layer. So if I come back to this picture, which I have created here, so this is my hidden layer, and this is my hidden layer as well, and this is my final layer or output layer. More the layers you will add, more powerful your algorithm will become. right? More the layers you will add, more powerful your algorithm will become. At the same time, more cost it will take as well for the processing. These layers are hidden layers. More the hidden layers, more the hidden layers, more deeper you are going. Or I can say more deep. Deep as in more layers are there. That means more deeper I am going. That's why the name deep learning coming into picture. Right? The name deep learning came in because there are multiple layers which we are having. So now what happens here? I will connect this x1 with my first function f1. I will connect with the second function f2 and so on and so forth. Same way this guy will connect to 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 this. Same way this guy will connect to this guy will connect to this, and connect to this. Same way now further it will connect to this, connect to this, connect to this. This type of network is known as fully connected network because all the neurons are connected. These are also known as neurons. These functions are also known as neurons because it is coming from the human brain. The idea is coming from the human brain. Right? So this is my fully connected network where this is my hidden layers. These are my hidden layers, I can say, and this is my output layer. Right? And these weights will get the importance based on how important that feature is. It will take combinations as well. That experience plus education both are important together. So your this will become very heavy or this will become very the weight will become high like that, right? So that is how the weight will be coming in. And we have to train all these weights. We have to fine tune all these weights. How many weights are there? How many weights are there? You can see here three inputs and four neurons. 3 into 4 is 12. There are 12 weights plus four neurons and three neurons. Again, there are 12 weights. And from 3 to 1, 3 weights. So 12 plus 12 plus 3. That is coming out to be 24, 27 weights. So we have to fine tune 27 weights, right? We have to fine tune these 27 weights. Just imagine when we are having a deep neural network, how many weights we have to fine tune. As of now, I just created a simple network, which is like only 27 weights. 12 weights here, 12 weights here, and 3 weights here. These are the weights, right? So these are the weights which I have to fine tune. So that is about the idea here. That is what I have mentioned here as well. So let me show you this. Right, so you can see here we have x1, x2, x3. We have the neuron. Neuron is basically nothing but the function. It can be any function. We are going to learn different functions over the period of time. Three functions are quite popular. One is known as 10H function, which is also known as activation function. All these functions are known as activation functions. We have the sigmoid function, which is also one of the activation functions. And third is the ReLU function, which is also one of the activation functions, right? So basically the idea is that I can pass these activation functions in my network. For example, let's say I want to predict the salary and let's say I have these neurons and there's the final neuron. So here I'll pass maybe ReLU function. I'll pass ReLU function. I'll pass ReLU function and here I'll pass linear function, right? Linear function. Why I'm passing linear function? Because I want a numerical value. I want a real value, right? I'm not looking for any yes or no type of prediction. I want to predict the car price. So car price will be a number. So I want to predict that number. So that's why I'm going with a linear function. If let's say I want to predict whether something will happen or not, in that case, this linear function may change to sigmoid function. Sigmoid function gives me the value in the 0 and 1, right? 0 means not happening, 1 means happening. So that is how we can create the entire neural network. Okay. Now what we'll do is we'll quickly see how we can implement this in Python. I've created one simple example on Python as well. So let me open the code. So here you can see that some of the codes are available. So let me quickly open this train model. So in this, I'm using the TensorFlow, which is one of the packages in Python. I am going to use Keras, which is one of the packages in Python as well, coming from TensorFlow. And I'm using this one of the salary data. Let me quickly show you the simple salary data which I have used. So here is the salary data which I'm using for creating the model. Again, the main idea was to help you understand how we can build the model. We can use some complex data as well. But I am again, the assumption for this session was that you guys are very much new and you are not aware of the concepts. So that's why we are basically discussing this. Are you guys able to hear me loud and clear? I see some of the chats coming in. Are you guys able to hear me? Are you guys able to see my screen as well? Okay. So let's proceed. So now if you see, this is my data set where I have this X, right? I already told you that this is my X, that is nothing but my independent variable. And I have the Y, which is the dependent variable. I'm running my business for, let's say, quite some time. And I have this data set with me. Again, it's a small data set, just 30 records, just for helping you understand how we can train the model, right? We can work on big data as well. So this is my data set on which I want to train my model. So what will be the step? The step is that I will load the data. I will load the data. I will do all the data cleaning if required, like missing value treatment, outlier treatment, and so on. I will do some feature scaling concept also. Feature scaling is basically nothing but where I am converting the value in unitless, right? Because see here, this year is experience is in the year and your salary is in the dollars or rupees, whatever it is. Both are in different units, right? So I want to make it unitless. There are various techniques are available to make the values unitless. Scalar transformation, your robust transformation, normalization, various different options are available. I used scalar in this scenario. Scalar is nothing but my new value will be xi minus the average of x upon standard deviation of x. For example, this is my x. I will take the average of the salary. I'll take the standard deviation of the salary and I will calculate. For example, 1.1 is the experience. So 1.1 minus what is the average experience? Let's say average is, let's say 3 upon standard deviation is, let's say 0.5. Let's assume. So 0.5. So whatever value I will get, right? This value will be replaced from 1.1 to that value. Same thing will happen for the next also 1.3 minus 3 upon 0.5, 1.5 minus 3 upon 0.5, and so on, so forth. So that is how I'm making my values in a standardized value. And same thing will happen for the salary also. So when you're doing the standardization, the value will vary from -3 to +3, right? Mostly the values will be varying from -3 to +3. If there is an outlier, maybe that will be higher than -3 or higher than +3, right? Normally the value will range from this. So if you go back to this, you can see that the same thing is happening here also. So this is the code where I have loaded the data set, right? Salary CSV. Then I am breaking this data into X and Y, where X is nothing but my independent variable and Y is nothing but my dependent variable. Once that is done, I am breaking this data into train and test as well. Here you can see that I am breaking this data into train and test because I told you that I am going to create a model where on the training data set, I will create the model and on the testing data set, I will test my model. So same thing is what we are going to do here as well. I am breaking this data into, which is my X and Y. This data I am breaking into train and test, making my test size as 20%. That means if there are 30 records, 20% of the records will be going into the testing data. Roughly 6 records will be going to the testing data. And rest of the 24 records will be going to the training data set. That means my model will get trained on the 24 data sets and 24 rows and 6 records we are going to use for the prediction point of view or for the testing point of view, right? Then I'm doing the standard scalar, this formula which I have just mentioned in the Excel, xi minus mu x upon standard deviation of x. That is what I'm applying here on the training data set and the testing data set, because I want my values to be in the same scale, right? So I'm doing in the training this x, and that is done. Once that is done, I am going ahead and I am creating my ANN model, where you can see that I'm using the keras.sequential. Here you can see, this is important to understand that your input is only one row because we are using only experience for predicting the salary. So I have only one column, which is your experience. And here you can see I am creating 3 layers, right? Layer number one, which is your 64 comma activation value. Layer number two, 32 comma activation value. And then the dense one output layer with a linear activation for regression, right? Now, what does this mean? Let's try to understand this. We are creating the network, something like this, right? This is a network where I have this axis, I have this hidden layer number one, and I have this hidden layer number two, and I have the output layer. In my axis, I clearly mentioned that I have only one input. That means my network will be only one input. That is X1, or I can say experience. Because that we have seen in our data set also. That we have seen in our data set also. We have only one X, right? So that is what we are passing here as one input, which you can see here. Input shape is 1. 64 comma activation equal to value. That means what? The first hidden layer which I have, it consists of 64 neurons, right? It consists of 64 neurons and all are ReLU activation function. That is what this is saying. With just 30 records, 64 activation function is actually not required, right? I just randomly put the values here. I can make it 2, 3 also. That is fine, right? Because the data is not that much and it's not very complex data. So I'm okay to have lesser values here as well. Second hidden layer was, if you see, this is my second hidden layer, 32 ReLU activation function. So my second layer is obviously half of this 32 activation function. That is also ReLU. And then finally my output layer. My output layer is only one neuron. My output layer is only one neuron. And that is what? That neuron is nothing but your linear activation function. And all are this connected with each other. All are connected with each other, right? So that is how the entire network which I have built here using the ReLU and then the final linear activation function, right? Once this entire network I have decided, after that I am using this, I'm compiling the model where you can see that optimizer equal to Adam, loss equal to mean squared error. I already mentioned about the mean squared error, right? That is nothing but to reduce the error. We have this formula. MSE is equal to 1 upon n, summation of I is equal to 1 to n, yi actual minus yi predicted whole square. So this is my mean squared error. So that is what it is taking for calculating the accuracy of the model. Adam is nothing but one of the optimizers. There are different types of optimizers are available, like your gradient descent is there, Adam is there, and a lot of other optimizers are also available. Adam is by now is the state of the art optimizer, which people are using quite extensively, right? So that is what we are passing here. After that, I'm using the training data set X and Y trained scaled, which we have created at the top, and epochs, batch size, validation data, and all those things are going on. Now, what are epochs and what is batch size? Let's try to understand this. If you remember, I have mentioned here, in one of the pages I have mentioned that we are going back, right? Let me show you again. Yeah, this one. So we are predicting the value and we are going back and improvising the weight, right? Again, we are coming back, doing the prediction. Again, we are looking for improvising. I will go back, I will improvise, come back. Go back, improvise, come back. Go back, improvise, come back, and so on, so forth. Epoch means 200. Epoch means nothing but this will happen 200 times. This epoch, which you can see in the code, that is nothing but 200 times this entire cycle will run. That means my weight will actually change 200 times and it will go to the best weight. I can reduce this epoch. I can increase this epoch. If you increase this quite extensively, your chances are very high that your model may overfit, right? If you reduce this quite extensively, the chances are there that your model is not very well fit, or I can say your model is underfit. So you have to find the best epochs, right? That is one of the hyperparameters which you have to fine tune. Batch size is nothing but there are 24 records in my training data set. At the one epoch, 4 records will come together. All the things will happen. Error will be coming in, goes back. In the second run, another 4 records will come. Third run, another 4 records will come, and so on, so forth. So batch size is nothing but at a single point of time, one epoch will take 4 records, and then it will go ahead and it will execute. Find the error, fix the error, change the weight, again another 4 records, and that is how the entire cycle will be running in. Once that is done, I am saving the model in the Keras. So this is the model which I am saving, salary model.keras. And once I am saving it, this model I can very well go ahead and I can put it in my front end. I'll show you the front end as well. And I'm also exporting some of the scalar values. That is nothing but the value of X and Y as a pickle file in Python. And one model is also have saved and my model saved successfully. You can see the same model in this folder as well. If I go back to the folder. So here you can see that I have the model file, which is the Keras model file, and I have 2 pickle files as well, which is nothing but my scalar value file for the same, right? Once that is done, I have created this application as well, which application is like a front end application. I was using the Streamlit package, which is coming in Python. So here you can see that I'm using the Streamlit package and I'm calling the model salary model.keras, which I have saved in this particular folder. And then I am again compiling the model, which is going to do the prediction for the new records. I'm calling my scalar files as well. And these are the titles which I'm giving to my front end. And I'm giving user an option to select the years of experience. And once user will pass on the years of experience, it is going to predict the salary. You can see that input is coming from the user, which will be scaled. Once that is done, it is going to be running in the model, predict the input value from the model, and the output will be coming in as a predicted salary once I inverse transform. Now, inverse transform is what? Try to understand again. If you remember, I was changing the experience, right? Experience I was changing to xi minus mu x upon standard deviation of x. So my original X new was not the original salary or original experience, right? For example, let's say I'm having experience as 1, 2, 3, 4, 5, and I want to make it unitless. So what I did, I took the average, 3 is the average. So 1 minus 3 upon standard deviation. So my first value will become this value. My second value will become 2 minus 3 upon standard deviation of X, this value. My third value will become 0 because 3 minus 3 is 0. Fourth value will become 4 minus 3 upon standard deviation of x. That is my fourth value. And my fifth value will be 5 minus 3 upon standard deviation of x. That is my fifth value. So that is what I am doing here as well. Whatever input I am passing, let's say I am passing 5 years of experience. So it will convert back to the scaled value, which will be passed in the model. Prediction will be coming in. Prediction value will also be coming in the scaled value, my experience and my salary. My salary is also scaled. So that will also be coming in a scaled value. For example, let's say my salary is coming out to be 3.5, but 3.5 is what? 3.5 is nothing but whatever your, so 3.5 is the X new or Y new. And I have the actual YI minus average of y upon standard deviation of y. I have this information, and this information. So I can very well calculate the yi as well, which is the actual predicted salary. So this inverse function is actually doing that. Inverse function is converting this scaled value to the original value, right? So that is what this function is doing. And once that is done, it is going to predict my entire salary. So let me launch this. Let me launch this application. Let's see what is going to happen. My model is already trained. I have all the pickle files and everything in the front end. I have already written in the code. I am just calling my model and let's see what's going to happen. So here you can see that it is launching my model in the web browser. This is the web browser opening up. As of now, it's a simple model. Only one feature is there. That's why you can see only one option is available where I have to pass the years of experience. Let's say I'm passing the years of experience as 5 years and I will predict the salary. Under the hood, if you open this page as well, because here you can see that it is launching. Let me click on the predict and let me see. You can see here, right? It is executing the model here. And once it executed the model, you can see the predicted salary coming in. That is coming out to be $65,000. If I go and if I change to, let's say 1 year, it will predict 39,000. If I make it 0 years, it will predict certain salary and so on, so forth. If I say 100 years, it is going to give me some big value. You can see I have written the code in a way that the value should not be more than 50, right? So if you go back to the code as well, here you can see the max value which I can take as 50 only. So let me pass 50 only. And once I do the prediction, I am getting some error that because the model is not trained with that particular number, right? Because if you see, if you go back to your data set, your data is having maximum of 10 years of experience. So model is not well trained. That's why the error is coming in. Let me relaunch this model. So once I relaunch this model, this page is coming in. And let me pass on the value in the range of 0 to 10. Let's see if it's working fine or not. So I'm passing 10. It is again giving some error. So it looks like there is some problem in the code, which I have to fix. But for the smaller number, it was looking perfectly fine, right? So that is how we can build the model. That is how we can create the model. And that is how the entire ANN works. The conceptual understanding is this is what the idea is, that you have to create a neuron, which is basically the function which will help me to predict the. This is the heart, I can say. This is the heart of the ANN. I am passing the inputs. This will do some maths on the under the hood and then give me the outcome. You can have the multi-layer network. You can have a single layer network. More the deeper network you guys will have, more the powerful the algorithm will be, right? So that is the idea. That is what I wanted to discuss. Any doubts you have, let me know. We can have a discussion on the chat. So start working on it. If you are not aware of all these things, play around with it. Try to get the understanding because things are quite drastically changing in the world of AI. And we should be very much on the lines, right? We should be very much on what's going on and we should be adapting the things, right? That is the idea. That's why I came up with this entire series where I can give the brief understanding of the concepts. Again, it's a big subject. I just gave you the brief idea that this is how it works, right? We can talk about this like in many, many hours, but I just wanted to give you the idea that, okay, this is what is happening and this is the step which you have to take for understanding the entire concepts. We are going to understand all the latest state of the art network as well, which we are going to understand in the future sessions. How much training is considered as good training? See, again, as I mentioned, we don't want to overfit the model, right? So if the prediction salary is 10,000, actual is also 10,000, that means you are overfitting the model. So that is not well trained, right? The idea is that whatever training error you are getting and whatever testing error you are getting, the difference between that should not be very high. It should be very much in a lesser side. So there is a concept of bias and variance. So let's say I'm setting certain hyperparameter here. Here I have the training data set and testing data set, right? The plot looks something like this. Let me just show you, right? This is the plot where this is, let's say, my uh, testing error, and this is my training error. And here, this is my training and testing both, right? This place will be the best place for me. Whatever hyperparameter I am choosing is the best hyperparameter. It depends on which type of algorithm you're using, the hyperparameter which you have to tune. So this is the best hyperparameter for me because here my training error and testing error both are in the near range. You will say here also it is near range, but here the idea is that the error is more, right? Here the error is less. Here you can see that your testing error is very high, training error is very less. That means you are overfitted model because you are very well doing in the training, but when the data is changing in the testing, it is becoming worst. Here, your training and testing both are high. That means you are not well trained. That means you are underfitted model. So the best part is here, which is also known as bias and variance trade-off. So this is the place, or this is the hyperparameter will be considered as the best hyperparameter. So how much training is considered to be good training? If I choose this hyperparameter, whatever machine is learning, that is perfectly fine for me, right? That is the answer. Same thing, right? How to decide the number of epochs? This is how we can decide the number of epochs. Okay. Because epochs is also one of the hyperparameters, so we can decide through this. Any books? There are a lot of books available, so I cannot suggest any book because I prefer to do hands-on and I prefer to see videos and all if I want to know something new. So as such books, I am not sure, but yeah, there are a lot of books available. You can explore that. You will get the recording, yes. You can go through the recording as well. Again, the main purpose of this session was to give you the idea that what is actually ANN is. Again, I told you it's a big subject and a lot of things which we can cover on this. But the motive of this session was to give you the idea that what it is, right? Then you can start exploring and you can start playing with these things. What prerequisites still skill required to attend this training? You should be aware of what machine learning is. You should be aware of what Python is. I think that is more than sufficient, right? If you're not aware of that, maybe we can plan one machine learning series as well soon. But yeah, that bit of idea you should be aware of. Maths again, uh, see this particular session is to help people understand who are coming from fully non-technical background. The main motive for this session is to understand that how ANN works. I'm not expecting you guys to write the code clearly. I'm not expecting you to understand the maths behind it. The expectation is that you should be aware that, okay, this things can be happen. These things can be done, right? That is the main idea of this session. So if you are not aware of machine learning in this session, we are okay. If you are not aware of Python in this session, we are okay. But yes, you should be aware that after completing this session, you should be aware that, okay, I can do this type of things using using the tool called Python, using the tool called ANN. That is what I understood. Then you can further explore from your side. You can ask your team to think about how we can implement that. So that is the whole motive of this session, right? And for the future sessions as well. So if you're already aware of all these things, then this session is not for you. But if you're very, very raw, then these sessions are for you. All right, anything else? Let me know. Else I'm good. Thanks for your time and we'll see you in the next time. Till then, take care, guys. I'll wait for 2 minutes. Any doubts, you can ping me on the chat. Can I suggest some topics from where we can start in AI? Start with ANN again. ANN is the topic which you can start. Explore that. We have a next session on CNN next week. So before that, you should be very much clear what ANN is. You should be having idea that what ANN is. You can look in the YouTube as well. A lot of videos are there. Then next week we'll talk about CNN where we can process the images, right? We can do predictions on images. So that is second topic. Then RNN comes in, recurrent neural network. We'll understand that what recurrent neural network is, which is the base of this entire chat GPT and all. So the story started from recurrent neural network. So we'll discuss more of a understanding of recurrent neural network. Then we'll proceed further, talk about encoders, decoders, and so on and so forth. Right. So whatever we are going to discuss in these series, those topics in depth, you have to go, and if you're looking for building the solution, then in that case, you have to go in depth of this. For this session, it's like more of understanding that what these terms are, right? So that was the main idea for this session. All right. All right, guys. So we'll see you in the next session. Till then, take care. Have a nice day.